When mathematicians use a procedure repeatedly, they often try to find a formula for the procedure. The quadratic formula condenses into one calculation the many steps used to solve a quadratic equation by completing the square. Here we have some examples of equations with second-degree terms. We can use the quadratic formula to solve quadratic equations. If the quadratic equation is in the form of ax squared plus bx plus c equals 0, in other words, standard form, then we can use the quadratic formula shown here, where a is the coefficient of the squared term. It's underneath the radical as well as in the denominator. B is the coefficient from the linear term, which is used in two places in the quadratic formula. And then C, the constant term, which is here shown underneath the radical as well. So let's take a look at using the quadratic formula to solve this quadratic equation. This equation is in standard form, which allows us to determine the value of A, which is 4, B, which is 5, and C, which is a -6. Replacing these values for the variables in the quadratic formula, we now have the opposite of B, -b, plus or minus B, which is 5 squared, minus 4, times A, which is 4, times C, which is -6, all over 2A, and A is 4. Next step then is to simplify this quadratic equation, and we'll focus our attention on the quantity underneath the radical. We want to simplify this expression into a single value for the radicand. Following order of operations, we'll square the 5, and while we're at it, multiplying a -4 times a -6 results in positive 96. Adding those two values together results in the square root of 121. Continuing to simplify this expression, square root of 121, since it's a perfect square, results in x equal to -5 plus 11 or -5 minus 11, each over 8. Simplifying this combined solution into the two possible solutions is the following. Solving then for the variable, we can add the numerator, giving us 6 over 8, and reducing results in x equal 3/4. In the other solution, -5 minus 11 results in a simplified or substituted value of -16 over the denominator of 8, which reduces to x equal -2, giving us the two solutions for the quadratic equation.